inverter. So in the first lecture of the mass inverter we have discussed about the mass inverter and their first VTC, voltage transfer characteristics, that is the ideal characteristics. So in this lecture we will discuss the continuous session of this voltage transfer characteristics of mass inverter. So here is the second one, is the critical voltage. So what is critical voltage? Basically the critical voltage, as shown in this figure below, these are the some points, some critical points where the voltage is changing according to the logic. When the logic is low, then the output at the output voltage is the logic high, logic, these type of the points that are the critical points, and the voltage on that points are the critical voltage. So the as shown in this figure, so these are the y-axis and these are the x-axis, and at the y-axis here we get the output V out, output voltage, and at the x-axis there is a V input voltage. We get the input voltage from x-axis. So this is the origin point, and this is the critical graph for measuring the critical points, critical voltage. Here VOH represents the output voltage at higher logic. So here the input is input at logic 0, that is the input voltage that is varies between the 0 to VDD by 2. When the input voltage is varies between the 0 to VDD by 2, then the input logic is 0, and when the input voltage is varies between the VDD by 2 to VDD, then the input voltage is logic 1. Means here this is the VDD voltage, here is the VDD, and here is also VDD. We can, here is the VDD by 2, VDD by 2 on the middle of this. So when the input varies between 0 to VDD by 2 here, then this at that point the logic is 0, and when this is VDD by 2 to here VDD input varies between this point to this point, then the input has logic 1. So come to the critical points. Here this is the VOL, the output voltage at lower logic. This is the VOH, the output voltage at higher logic. So when the input voltage VIL at the lower logic means 0, then the output voltage is at the high VOH. We get the VOH from this point, and at the middle of this point, this is the VTH, threshold voltage. We can calculate this with the help of the input voltage, so that we can discuss later. So next, at that point, this is the VIH. When the V means voltage, I means input, H means high logic. When the input voltage at higher logic, then we get the output voltage is VOL, voltage at output voltage at lower logic. So and after that the output VOL is at the saturation, is in the saturation position. It is the saturation. So here after that the VOH is in the saturation point. So this point, and this point means VOH and VTH and VIH are these points are the critical points. So the output voltage is equal to input voltage at the VTH, threshold voltage. So some points are the VIL represents the maximum input voltage at logic 0, VIH represents the minimum input voltage at logic 1, VOL represents the output voltage at logic 0 and VOH represents the minimum output voltage at logic 0. Some points you need to remember: I represents the input and O represents the output. L represents the logic low, means 0, and H represents the logic 1, means 1 logic, and V represents the voltage. This is the technique for remembering all these points. So let's move to the next slide. Here I have written I represents the input, O represents the output voltage, L represents the logic low, H represents the logic high. So OL represents the output voltage at low logic, means 0, and OH represents the output voltage at logic high 1. So the value of the input voltage at lower logic VIL and input voltage at higher logic VIH determined from the voltage transfer characteristics VTC curve. So the here at the point VOH in the graph, the value of the dV out upon dV in, output voltage upon input voltage, is equal to -1, and the VTH threshold voltage is determined by input voltage. So when the input voltage is equal to output voltage. So let's move to the third VTC, voltage transfer characteristics of the MOS inverter. This is a noise margin. So basically, what is noise margin? When any unwanted voltage or signal added to our voltage signal or desired voltage signal, then we call that particular voltage is noise, or that we call that particular voltage signal is noise signal. So when the noise exceeds some certain margins known as noise margin for the logic 0 and 1. So in case of input and output voltage, for the lower logic VIL and VOL means voltage, input voltage at logic low and output voltage at logic low. So if the input voltage VIL, input voltage at logic low, is greater than the output voltage at logic low, for low logic the input voltage is greater than output voltage, then there is no change in the voltage, means output voltage, no change in the output voltage. This is the output voltage.